National 5, we are going to Queen's Park with Nova for our morning dog walk, and I thought I'd explain Newton's 3 laws. So the first one is right now, because Newton's first law says that something will remain at rest or at constant speed unless acted on by an unbalanced force. And right now I am stationary because there's no forces acting. If I was going at constant speed, there would also be no unbalanced forces acting. Alright, so something remains at rest or at constant speed unless acted on by an unbalanced force. So let's jump to Newton's law number 2 in 3, 2, 1, go. Okay, National 5, we are at Newton's second law, F equals ma, which is basically saying that an acceleration is caused by an unbalanced force. So I'm going to show you F equals ma here with Nova. Okay, you ready? So moving on to Newton's third law, which is every action has equal and opposite reaction. So I'm sitting on a bench here and I have an action force that's pressing down onto the bench, but there's also a reaction force that's pressing back up on me. So that's why I'm not falling through the bench. Alright, so that's Newton's 3 laws, and we're just about coming to the end of our dog walk. So now it's time for me to explain a little bit more in the past paper questions in 3, 2, 1, and go. National 5, welcome back to another prelim revision, this time dynamics part 3. Hope you enjoyed our little escapade and a little insight into the morning with Nova and myself. Bit of fun there. So now we're going to be moving on to forces and chatting about forces, hence why I was chatting about Newton's laws in the various different ways. So let's actually get through. Guys, we're really close to 300 subscribers. So if you have not already clicked that bell, then you should be doing that now. Alright. So, dynamics revision part 3, and today's lesson is going to cover lots of things: Newton's first law, second law, third law, terminal velocity, and force diagrams. Lots of things to cover here. So, let's talk about Newton's first law, as I've mentioned before. So, Newton's first law, before we do that, let's talk about friction, because friction is fundamental to talking about forces. Okay, so friction is a force which opposes motion. You are probably aware of that. You should theoretically be quite aware of that because we have done lots of that in second year and first year science. So cars slow down due to frictional forces between the tires and the road surface, or when the driver applies the brakes, which causes a frictional force to be applied to the brake disc. Basically, anything that opposes motion is seen as friction. Alright, why is that important? Well, we are going to talk about that in different ways in terms of Newton's laws. So Newton's first law, and again, this is stuff that we should know in the red box. An object will remain at rest or move at a constant speed in a straight line unless acted on by an unbalanced force. So I explained that in the car. I was stationary. There was no unbalanced forces acting on my person and on the car. And when I move, once I got to a constant speed, so for example 30 miles an hour, unless there's an unbalanced force, I will stay at that speed. Okay. However, because we live in a real world, if I was to lift my foot off the brake, because of the friction between the tires and the road and other things like air resistance, I would slow down. So there would be an unbalanced force causing me to slow down. So, for example, in this one here, we have 10 newtons to the left, 10 newtons to the right. That is what we call a balanced force. Balanced and unbalanced forces are ways that you would describe something in an exam. Okay, so make sure you know what a balanced force is, and if something says balanced, then you should know that it's either stationary or at a constant speed. Okay, now that's a very easy one. There's not much of questions you can ask. However, Newton's second law is very important. Why? Because Newton's second law is basically just memorized by using this equation. You do not have to see if something says what is Newton's second law. You don't have to memorize a phrase. You just literally have to write F equals ma. F is the unbalanced force, so sometimes we say FUN, so fun, equals mass, kilograms, times the acceleration, which we've been talking about in the most recent weeks, which is meters per second squared. So F equals ma is an equation that will come up time and time and time again. So make sure again that you know that that is in your equation sheet. So let's look at some examples with regards to friction. So 3 examples that I have done answers to. An unbalanced force in example 1 of 75 newtons acts on a mass of 15 kilograms. calculate the acceleration of the mass. So that is a very, very, very straightforward question. That's just doing on the left-hand side there, F equals ma, A equals F over m, which is the rearranging. So obviously the force is 75, the mass is 15. 75 divided by 15 gives us 5 meters per second squared. So that would be the acceleration there. Okay. Number 2 says calculate the acceleration of the object below. So this is a classic example that you could get in a multiple choice question. So clearly we've got 3 newtons going to the left, 50 newtons going to the right. So therefore the unbalanced force is only going to be 12 newtons to the right, because 15 minus 3 is 12. So once we know that, 15 minus 3 in the middle there is 12, we then just do the same equation. A equals F over m. 12 divided by 3 this time, which is 4 meters per second squared. Okay? And the last one, example 3, calculate the frictional force. Well, this one's a little bit more tricky. So what do we have to do? We first of all have to find F equals ma. We have to find out what the unbalanced force is. Okay, so F equals ma first gives us 12 times 3, which gives us 36 newtons. Okay, so 36 newtons is the unbalanced force. However, there's a total of 60 newtons being added to the right. So if only 36 is given to the unbalanced force, then we must do 60 minus 36 to give us the friction forces, 24 newtons. So basically what we're seeing here is that it takes 24 newtons for us just to get this block off the ground or moving. And then everything else that's added onto that actually will move the object and accelerate the object. Okay? So pause that, see if you need to go through any of them yourself. But that's how you would do those questions. And they're typical force questions that you would get asked in multiple choices and in exams. Now, particularly this one here, this is always worth 4 marks in an exam. 4 marks. So let's read it. Calculate the engine force for this rocket to take off from the Earth with an acceleration of 4.8 meters per second squared. Assume frictional forces are negligible. Okay? So the only way to answer this is 4 marks. If you just did F equals ma, okay, if you just did F equals ma and did 1000 times 4.8, you would only get 1 out of 4 marks. Why? Because this rocket has a weight and you need to overcome the weight before it will start moving. So the first things first we need to do is do W equals mg. We need to find out the weight. So W equals mg is 1000 times 9.8. Now 1000 times 9.8 is 9,800. So you need 9,800 newtons just to get the rocket ship off the ground. If you don't, then you're not going to get it off the ground. Same idea as if you were to lift someone that you know. Unless you lift their weight, you're not going to lift that person off the ground. Okay? So, what do we then do after that? Well, we know that it accelerates at 4.8 meters per second. So, we can actually find the unbalanced force, which is F equals ma, 1000 times 4.8, which is 4,800 newtons. So the total force needed to get that rocket off the ground and accelerating at 4.8 meters per second is 9,800 plus 4,800, which gives us 14,600 newtons. So pause this video if you did not get that, but hopefully that makes sense to you. If it's 4 marks, this is exactly what you need to do. If it's 4 marks, this is exactly what you need to do. However, sometimes in other equations or other questions, you may have found the weight in a previous question and then it's just about adding them together. Okay? So make sure you know how to do that, because that's an important one. That always comes up. Right, Newton's third law. Newton's third law says that every action force has an equal and opposite reaction force, as I explained on the bench in Queen's Park. And we often get these things called Newton pairs. Now, lots of multiple choice questions in this. You normally get someone sitting on a bench or sitting on a chair, and it says something like, what is the Newton pair here? Or for example, if this woman is sitting on the chair, then the force she exerts on the chair is the same force that exerts back on her. Okay, there's a question on that, and it's just about making sure it's the equal and opposite. So if they give you a statement, it's just the opposite statement being said. Okay? So for example, the car is an example of a Newton pair. The tires push back on the road, but the road pushes forwards on the tires. Okay? The tires push back on the road, but the road pushes forwards on the tires. That's why the car moves forward. So Newton's third law explains that. Right. Another example, a rocket is pushed forward because the propellant is pushed back. So if we were to say the propellant gases push the rocket forwards, making it accelerate, the rocket motors push the propellant gases backwards. So something's going backwards and something's going forward. Same idea if you were to go swimming and you were to go to the end of the pool. If you were to press off of the edge of the pool, you would go forward, but you're actually theoretically pushing the wall backwards. Alright? So that's that there. Now, recap. Newton's first law, an object will remain at rest or travelling at a constant speed unless acted on by an unbalanced force. Newton's second law is F equals ma. Alright? And for force questions, draw a diagram showing all the forces acting on the object. So for example, a parachutist would be air resistance is going up the way and the weight going down. If a rocket was taking off, you would have air resistance and weight going down and then the rocket thrust going up. Classic questions will ask you to draw diagrams, so you need to know these forces. And then last of all, talking about Newton pairs and Newton's third law, which is every action has an equal and opposite reaction force. Okay. So, terminal velocity. Terminal velocity, this is the kind of the most important bit here. So terminal velocity is achieved when the frictional forces acting on an object falling through a fluid become balanced with the object's weight. Now, a fluid's a weird thing. Basically, anything that is falling when its weight is balanced with the frictional force, which is often air resistance in the term of what we look at when someone's falling in the sky, then when they're balanced, it reaches terminal velocity. Now, terminal velocity is a point where there's constant speed, so therefore the forces are balanced. Okay, so velocity on the y-axis, time on the x-axis. The parachutist jumps and accelerates downwards. So this is basically a velocity time graph. If we were to find the area under this graph, we would find the distance that the person travelled. But as we can see, there's a constant acceleration to start with. And then it starts to ever so slightly curve because it's reaching terminal velocity. The weight and the air resistance are becoming equal. Then we have a constant speed until the parachute opens. Now remember, common misconception, when a parachute opens, you're not going up, you're actually just slowing down. This often means that the person who's filming is the person who is still moving down really fast. So immediately I have very quick deceleration until we get terminal velocity 2, and then they hit the ground, which means that they go straight down and then stop moving. So that's an example of terminal velocity. So what would we say? Draw a diagram showing the forces acting on the Skydiver, a classic question. So let's look at that one first. So if we had the Skydiver, we have weight going down the way and air resistance or friction moving up the way. So that's a classic example of something with regards to forces. And then the second one says, calculate the value of the frictional force acting on the Skydiver. Now we're only given the mass, but as we've said before, weight and friction are obviously now balanced because they're moving at constant speed at terminal velocity. So when you see something at terminal velocity, you know that the forces are balanced. So weight and the friction force are balanced. So therefore the friction force is equal to mg. 65 times 9.8 gives us 637 newtons. Okay? So that's that there. Pause it if you need to look at that, but that's the answers to that question. Now, force diagrams. We did a couple of weeks ago basically the same thing here with Pythagoras and trigonometry, but for displacement and velocity. But this is the same idea. Force is another vector. So the resultant force is the one force that can replace all the forces acting on an object and have the same effect. We will use our right-angled vector diagrams to find the resultant force. So, very similar to last time, check the arrows are top to tail, so make sure that the arrows are not pointing in different directions. Make sure that it looks nose to tail, and I'm going to show you examples of that. Calculate the magnitude using Pythagoras, and then calculate the bearing using tan x equals opposite over adjacent. Okay, and remember bearings are taken from the start point, and you draw in the north line and go clockwise from the resultant. Okay, so everything we've done before is there. So 2 questions. Question 1. A parachutist is falling to the ground. She has a weight of 600 newtons and the wind force is 50 newtons westwards. Calculate the resultant force on the parachute or parachutist. So what we must do first is always draw a diagram. So the diagram here that I've drawn is 50 newtons west and then 600 newtons south, okay, or down the way. Now, when I'm doing this, have a look. The arrows are not nose to tail. They are going in 2 separate directions. So to make them nose to tail, I move it, so that means I move the bottom one, 600, along the 50 newton line until it's nose to tail. Now, if that was a human being in the left there, and you were getting pulled west and south, you would be going in a kind of a southwesterly direction. So the resultant is a very true representation of that. It's going, and in the resultant there's a double arrow, and then I've got the X because that's the starting point. The X there is the starting point. So that's how I've done that. So make sure you know how to go from the left diagram to the right diagram. Then it becomes super easy. 2 marks are always given to your Pythagoras. So a squared equals b squared plus c squared should be straightforward maths. That should be a guaranteed 2 marks. We get 602 newtons for that one. Then the tan x equals opposite over adjacent. 600 divided by 50. Once you get the diagram right, the key bit is the diagram. Once you get the diagram right, you will be sorted. So that's 85 degrees. And remember my little triangle design? I put that in there and I should get 270 minus 85, which gives me 185 there, which means that the resultant is 602 newtons at 185 for the full 4 marks. Okay? Now, number 2 says calculate the resultant force of the following situations. We've got 40 newtons up, 12 newtons going east. Again, they're not nose to tail. So what I've done is I've done what they've done there, but I've changed it and I've moved the top line along the 12 newtons and I've got a double arrow. Okay, so 12 newtons along the way, 40 newtons up, and I've put my X at the start point. Okay. Now, for this one again, a squared equals b squared plus c squared. You work that through and you get 41.8 newtons. And then for tan, it's just going to be 40 divided by 12, 73 degrees. However, remember, it's actually from the north line. So it's going to be 90 minus 73, that gives me 17. Because remember, if I fit that triangle into my little diagram that I showed you 2 weeks ago, you would get 90 minus the angle, which is 17 degrees. So the resultant should be 41.8 newtons at 0.17. So that there, again, pause it, look at it, see if you can understand that before you move on. Right, that is that. That is lots of force stuff. We're going to have past paper questions on this. This stuff always comes up. A good few, like 20 marks on the forces stuff. There's so many marks in an exam on this stuff, so make sure you know how to answer these questions. And the help that I've given you today should hopefully give you enough to do the questions today as well. Alright, National 5, well done, and I'll see you soon.